Good morning, students. In the previous session, I had defined two types of angles. One was angle of elevation and the other one was angle of depression. And using the definition, we had worked out three problems. Angle of elevation means when an object is above our level, above our horizontal level, then the angle that is covered by looking at that one is called as angle of elevation. Similarly, if the object is below the horizontal line, before our level, we have to look down, and that angle that is covered by looking down at the object is called as an angle of depression. Usually the definition is asked, but you have to know the definition, otherwise you cannot solve the problems. So in the three problems, we had calculated whatever has been asked in the problem, maybe the height of the tower or whatever may be that one. Now today also I am working out some problems. In all the remaining sessions, only the problems would be worked out. Now this is the problem I have to work out. I am working out now. What is the angle of elevation of the sun when the length of the shadow of a pole is 1 by root 3 times the height of the pole? So here what we are calculating, there are three quantities here, either the height of the tower or the pole or whatever it is, and the other one distance of the observation point of observation from the foot of the tower or whatever it is, and the other one is the angle of elevation or maybe the angle of depression. So here angle of elevation has to be calculated, but some condition is given here. The shadow of the pole is 1 by root 3 times the height of the pole. So using that condition, you have to get the angle of elevation. Now let me draw the figure here. So first we will be considering this one, a right angle triangle. Now let us take AB to be the pole here. Now sun is above this one, and the shadow is falling on the horizontal line. So this is, let me take it as BC. So AB is the pole and BC is the shadow of the pole. And what's the condition given? The shadow sun, when the length of the shadow of a pole is 1 by root 3 times the height of the pole. So if you take the height to be equal to h here, it is 1 by root 3 times means h into 1 by root 3, or you can write it as h by root of 3. So this is the height. We do not know the exact height here, it is given in terms of, I have taken it as h here. Let h be the height of the pole, then according to the condition that is given, it is h by root 3 is the length of the shadow. See, our problem is to find the angle of elevation. This is the angle of elevation. Let me take it as theta. Now, how do you find this one? See, for this angle theta, this AB is the opposite side and BC is the adjacent side. So, which ratio you have to consider? You have to consider the tan ratio here. Okay. So, how do you write this one? Let AB be the pole. Let AB be the pole and BC be its shadow. BC be its shadow. Now, let AB be equal to H. AB be equal to H. What may be the unit here? Let AB be equal to H. Then the condition, according to the condition, it is H by root 3 times. Then the shadow of BC would be equal to H by root 3. Now let me take theta to be the angle of elevation. Let theta be the angle of elevation. Angle of elevation. Now what is that we have to calculate now? To find theta. To find theta. So make it a habit to write all these things in these problems about the heights and distances. First you have to draw the diagram and you have to explain the diagram. What are all the notations you have used and how do you denote, how do you define those things, you have to write first. And what are the given things, what is given you write, then what has to be calculated you have to write, and ultimately using either the tan ratio, sin ratio, depending upon the quantities that are given, you have to find out. Now from the triangle ABC, consider tan theta. Consider tan theta. Tan theta, that is tan of ACB. For theta, I told you already AB is the opposite side, BC is the adjacent side. That is why I have taken tan theta, because this is the one which connects the opposite and the adjacent sides. So this is AB divided by BC. What is AB? AB has been taken as H and BC has been taken as H by root 3. This is given, the condition that has been given. H is the one which I have assumed, and because of the condition given, the length BC would be equal to H by root of 3. You observe that H and H now they get cancelled. Root 3, this being denominator of the denominator, goes to the numerator. That means tan theta would be equal to root 3. You know that root 3 is a standard value. When will be that equal to root 3? When angle theta is equal to 60 degrees. That implies that theta is equal to 60 degree, or if you write in radian measure, it would be pi by 3. But what is theta? Theta is nothing but the angle of elevation. Finally, you write, therefore, better write the answer in sentence. Therefore, angle of elevation is equal to 60 degree. So, here, though the length of the pole is not given, height of the pole or the shadow is not given, some condition is given. So, using the condition, I have calculated the angle of elevation. Now, that's what in this problem, there is some relation between the adjacent and the opposite side. So, I could take the angle, I could take the trigonometric ratio tan theta. Now, in all the problems, we need not take the tan theta. Depending upon what is the data, you have to decide about that one. Now, in the next problem also, we are calculating the angle of elevation only. But the condition is, and the data that is different. Now, let me take the next problem. Find the angle of elevation. Find the angle of elevation. Find the angle of elevation. What is given here? Of the sun, angle of elevation of the sun when the shadow of a tower 75 meters high is 25 root 3 meters long. 25 root 3 meters long. So here also, just like the previous problem, but the difference is, in the previous problem, the actual height of the pole was not given. I had assumed that to be equal to h. Whereas here, look at the problem. Again, we are calculating the angle of elevation of the sun when what happens? The shadow of the tower 75 meters high. That means the height of the tower is 75 meters. And then the shadow of the tower, which is 75 meters high, is 25 root 3 meters long. So, in this one also, there is a tower and the length of the tower is given and the length of the shadow is also given. Again, you have to calculate the angle of elevation. Now, let me take AB to be the tower and BC is the shadow. And what are the data here? It's 75 and this is 25 into root 3. So, here in the previous problem, it was the pole we are considering. Let AB be the tower and BC be its shadow. Now, here the exact value has been given. So, what is given? Let me write it. Given AB is equal to 75 and BC is given to be 25 into root of 3. So, these are the data. And what's the next one? Theta be the, again I am taking theta to be the angle of elevation. Our problem is to find the angle theta. So, from the same triangle ABC, which I have denoted as ABC only. So, from the same triangle ABC, observe here also for angle theta, this is the opposite side and this is the adjacent side. So, which ratio? You have to again consider the tan ratio only. That is tan of theta. Tan of theta means again AB divided by BC. What are AB and BC? The exact values have been given. It is 75 divided by 25 into root 3. Some simplification you can do here. You can cancel 75 by 25. How many times? 3 times. 25, 3 is 75. That means I am having 3 divided by root 3. Again you can cancel this one. By root 3 you can cancel 3. How many times? Root 3 times only. So again we are having tan theta is equal to root 3. Again, being a standard value, in this problem also, I am getting the angle of elevation to be equal to 60 degrees. So how do you write this one? Again, you have to write, in the previous problem you wrote the height of the pole is equal to 6, that the height of the pole we have taken h and we took it as h by root 3 because that was a condition given. We wrote here the angle of elevation in the previous problem was 60 and here also the angle of elevation is equal to 60 degrees. Okay. Now another problem, I am telling you all the problems we need not use tan theta only. Maximum problems, I can say about 99% of the problems I will be using the tan ratio only, but one or two problems here and there we may have to use either sin theta or cos theta depending upon the function, depending upon the data. Now let me consider another problem. Again here also we are calculating the angle of elevation, that is a kite flying at a height of h. Here again in general h is given. A kite flying at a height of h, is tied to a thread, to a thread which is 500 meters long. 500 meters long. Assuming that there is no kink, K-I-N-K, kink in the thread, and it makes an angle of 30 degrees with the ground. It makes an angle 30 degrees with the ground. Find the height of the kite. Find the height of the kite. Find the height of the kite. So here the angle of elevation has been given. Okay, let us read the problem and understand what is given, what has to be calculated. A kite is flying at a height of h units. Okay, first let me write that one. Now let me take A to be the position of the height. Now to a thread, and h is a height h is tied to a thread which is 500 meters long. Now this is the thread. This is the thread which is 500 meters long. So let me take this as A, B, C. Now A is the position of the kite and it is flying at a height of h units. Now this is the ground level, this is the position of the kite, and this AC is the thread to which the kite is tied. Now assuming that there is no kink, that means there is no knot or anything in between. So AC is a straight line we are considering here. And it makes an angle of 30 degrees, that is the thread is making an angle of 30 degrees, that means the angle of elevation is 30 here. With the ground, find the height of the kite, that means at what level the kite is flying, that in other words you have to calculate h here. Look here, h is the unknown quantity which has to be calculated. For this angle 30, the angle of elevation, the opposite side has to be calculated, and in this problem the hypotenuse is given. So which is the ratio which connects this one, the opposite and the hypotenuse? It is nothing but a sine ratio. So that's what I am telling you in the previous problems also. Depending upon the data, you have to think about the particular ratio that has to be selected for the problem. So let me explain what are the according to the diagram, what is that we have defined and denoted in this problem. So what I have to write here? Let A be the position of kite. Position of the kite. AC is the thread. AC is the thread. It is given to be 500 meters. And then let, and what is other data? Angle ACB is given to be 30, which is nothing but the angle of elevation. And let AB be equal to H. Of course, it is already given. AB is H, it is already given. So what has to be calculated? To find H. That is our ultimate aim. That is, we have to calculate the height. That means at what level the kite is flying. Again, it is a right angle triangle. Just now I told you for the angle 30, this is the opposite side and that is the hypotenuse. Therefore, in the triangle ABC, consider sine of angle ACB. Sine of ACB, that is AB divided by AC. Now what is ACB? Let me write that one. Sine of 30 degrees equal to H divided by 500. What is the value of sine 30? It is a standard value, hence it is half is equal to H by 500. Now on cross multiplication, you can write H would be equal to, take 500 to the other side. So 500 divided by 2, it is exactly divisible, therefore 250. What is H here? It is the position of, the height here. In other words, the position of the kite. So what we can say, the kite is flying at a height of 250 meters from the ground. So they have asked the problem, find the height of the kite. So answer, you have to write the height of the kite. The height of the kite. Height of the kite is equal to 250 meters. Or you can write the answer like this also. The kite is flying at a height of 250 meters. Both the way the answer can be expressed here. Now, one more problem. See, in some problems we calculate the height of the pole or height of the building or height of the tower, whatever has been given in the problem. Sometimes we calculate the angle of elevation. Sometimes we calculate this horizontal distance. That means at what distance the point of observation is given on the horizontal line. So depending upon the question or the data, we have to write. Of course, in all the problems we will be having a right angle triangle only. So using the right angle triangle, we can get the required answer. Now next problem. A ladder leaning against a wall. A ladder leaning against a wall makes an angle of 60 degrees with the ground. If the foot of the ladder is 6 meters away from the wall, find the length of the ladder. Find the length of the ladder. So let me read the problem and let us see what is that we have to calculate and what has been given in the problem. There is a ladder. A ladder is leaning against a wall. So let me take AB to be the wall. Let AB be the wall and then AC be the ladder. AB be the wall and AC be the ladder. It is leaning against the wall. Now, A ladder leaning against a wall makes an angle of 60 degrees with the ground, that is angle of elevation. In other words, the angle of elevation is 60 degrees. If the foot of the ladder, what's the foot of the, this is the ladder means this is the top portion, this is the bottom portion, this is the top end, this is the bottom end. So if the foot of the ladder is 6 meters away from the wall, so 6 meters, that is this distance is given to be 6 meters. 6 meters. So these are the two data. And what is that we have to prove? From the wall, find the length of the ladder. That means that what has to be calculated? AC has to be calculated. So here, we are not interested about this one, height of the wall here. A ladder is leaning against a wall. This is the top part, this is the bottom. Okay, top end and the bottom end here. The ladder is making an angle of 60 degrees with the ground. And this is the ground. This is the wall and this is the ground here. Now this, the bottom end of the ladder is 6 meters away from the wall here. So this is known that for this angle, this BC is the adjacent side and we have to calculate AC. Okay, that is nothing but the hypotenuse. So which is the ratio which connects here? The adjacent and the hypotenuse, it is nothing but the cosine ratio or the cos ratio. So this one, let me, you need not, you can take it as L or X or whatever may be that one. Now we need here the distance AC. So let me write the, let me explain the figure. Let me define what I have written here. Let AB be the wall. Let AB be the wall and AC be the ladder. AC be the ladder. Of course, BC is the horizontal or the ground, I mean. What is given here? This we have made the assumption. We have assumed that AB is the wall and AC is the ladder. Given angle ACB equal to 60 degree, which is nothing but the angle of elevation. And what is the other data? BC is given to be 6 meters. Now what we need here? The length of the ladder. Length of the ladder, that means that we have to calculate to find AC, or you can take it as L or X or whatever it is, or you can keep it AC itself. So here again the same triangle ABC only I am considering. So from the triangle ABC, I told you just now the adjacent side and the hypotenuse. In this case I have to consider cos theta. Consider cos of ACB, cos of ACB, that is according to the definition, it is the adjacent side divided by the hypotenuse. So BC divided by AC. Now let me write actual value, that is cos of 60 degree. BC has been given as 6 and AC we have kept it as AC only. Now let me write the actual value of cos 60, which is a standard value. That means 1 by 2 equal to 6 divided by AC. Now to get the value, what you have to do? You are nothing but cross multiplying. If you cross multiply, we have AC into 1 equal to 2 into 6. 2 into 6 means it is 12. So the unit that is given is meters. So the length of the ladder is nothing but 12 meters. So finally write the answer. Length of the ladder. Length of the ladder is equal to 12 meters. See, you have to see in the previous problem we consider the sine ratio because the adjacent, the opposite side and the hypotenuse had to be connected. In this problem we had the adjacent side has to be connected with the hypotenuse, so we have to take the cosine ratio. So the length of the ladder is 12 meters and the lower end is from the 6 meters away from the ground, from the wall here. So this is 6 meters, the angle is 60 degrees and the length length of the ladder is given to be 12 meters. So these are problems can be expected just for a 2-mark question. Usually in your question paper so far, a problem for 4 mark in part E is given. Therefore, they may combine, some extra thing can be asked with this one. So these are the problems which can be expected for a lower mark question, that is for a 2-mark question. In the coming sessions, I will be working on problems which would be usually asked for a 4-mark question in part E. Thank you.